This is the Illinois Tollway, 187 miles of driving pleasure.
Although the roads in this 1959 ad are practically empty, ask anyone who drives in Chicago today what it's like, and you'll usually get something closer to this.
It makes me question living in Chicago.
Our expressway design is really pretty suboptimal.
Traffic is very heavy now.
One of those days where it took almost an hour and a half.
By annual hours lost per driver, can you guess which city ranked #1 in the US in 2025? Not New York, not Los Angeles, not Atlanta, and not DC. It was Chicago. And that's the context for this project. Chicago's congestion concentrates on a few corridors where demand, freight, and geometry collide, and when one of them slips, the whole network feels it. One of the biggest is Interstate 294, the same road the advertisement was trying to get more people to use. But before we get into the colossal $4 billion rebuild, you need to understand the engineering problem that kept pulling this road back into congestion. To explain it, I traveled to several spots along the corridor. Interstate 294, also called the Tri-State Tollway, is Chicago's main north-south bypass on the west side. It's the connector that ties the region's biggest highways and job zones together without going through downtown. From the south, it picks up flows from I-90 and 94 in the industrial and logistics belt that sits along that corridor. Moving north, it intersects I-57 and 55, then plugs directly into the 88 and 290 spine that serves major suburban office parks, industrial areas, and freight activity across the region. Near the top of the corridor, it becomes the approach system for the O'Hare area, where airport passenger trips overlap with cargo, warehouses, and distribution facilities that cluster around the airport's highway access. That geography forces very different trip types onto the same pavement. You've got long-distance trucks using 294 as a clean way to exchange between interstates and avoid the tighter, merge-heavy downtown expressway core. You've got regional freight and service fleets doing shorter runs between the I-80 logistics belt, west suburban industry, and the O'Hare cargo district. And you've got a huge volume of suburb-to-suburb commuters who aren't trying to reach the loop at all. They're just moving between employment centers on the edges of the metro. The same logic shows up for through travelers too. If you come in on I-90 and need to continue north toward Milwaukee, the choice is essentially staying on the core routes through the city or taking 294 as the beltway and rejoining 94 north. Most of the time, even after accounting for traffic, the beltway option tends to be faster. The operational problem comes down to a simple mismatch. I-294 ended up playing a major high volume role in the region, but much of its geometry was drawn for traffic in the 1950s, a time when driving looked more like this, and Mary McToll was singing this.
Oh, ye'll take the highway and I'll take the tollway, and I'll be there safely before ye.
And as of a few years ago, you still saw that in the layout. Interchanges packed close together, loop ramps designed for lower speeds, and not enough auxiliary space between ramps to let entering and exiting traffic sort itself out. In several spots, ramps are so close together that drivers have to merge in and peel off again almost immediately. So all that weaving happens in the main lanes instead of being separated onto collector-distributor roads. And weaving is a capacity killer. Every lane change is a small interruption, and when enough of those stack up, the roadway's usable capacity drops well below what the lane count implies. Even in this screenshot, when there's no traffic at all, the short merge distances forces things like this. And heavy trucks make it worse because they accelerate more slowly and need bigger gaps, which forces more braking and more ripple effects through the flow. That's why the corridor kept snapping back into congestion even after two widenings in the 1970s and early 90s. The legacy design also made everyday disruptions hit harder than they should. With limited shoulders and tight recovery space, a disabled vehicle, a minor crash, or even a traffic stop can take out a live lane and instantly knock the corridor into stop and go. And because there aren't many parallel routes with comparable capacity, even small incidents propagate rapidly across long segments. So the real question is, if widening alone didn't stick last time, what's so different about rebuilding the corridor from the ground up? Instead of chasing congestion with isolated fixes, the Central Tri-State project is completely rebuilding 22 miles of 294. In most stretches, the main line is being expanded from 4 lanes per direction to 5, and in selected areas to 6. The cross-section is also being rebalanced for reliability. The inside shoulder is designed to double as a managed flex lane, meaning it can operate as a travel lane in periods of heavy congestion or during incident response, but otherwise remains a full-width shoulder for breakdowns and emergency access. Along with that comes wider outside shoulders and new median barrier systems. Bridges are also a big share of the work, because the widened roadway and shoulders don't fit with many 1950s era structures. The signature example is the mile-long bridge, where 294 crosses the Des Plaines River, the ship canal, and railroads. The original 1958 viaducts used dozens of short spans and many piers. The replacements are 4,800 feet long each and use longer spans to roughly halve the pier count. The superstructure blends long span steel girders with large precast concrete beams. Construction was staged: build one span beside the old, shift traffic, demolish, then build the second. At the major BNSF railroad crossing, the key constraint is trains have to keep running. The bridge carries a busy triple-track main line, so the project built a temporary bypass alignment, a shoe fly, essentially a short detour track constructed along the existing railroad with its own ballast section and turnouts at each end. During a planned cutover, trains are shifted onto the shoe fly under reduced speeds, which clears the original bridge footprint so crews can demolish the old structure and build a new steel girder span with a wider opening over the road. But the project is also addressing the interchange geometry problems. The centerpiece is the I-290 and 88 complex, which is being rebuilt with more direct ramps and collector-distributor roads, so entering and exiting traffic can sort itself out without disrupting the main line. Because the site is flood-prone and packed with utilities and soft soils, the work also includes added detention, major utility protection, and ground improvement. 294 is also getting intelligent transportation systems, or ITS. This includes things like gantries, lane control signals, message boards, cameras, sensors, and fiber, all of which is to support active traffic management and safe operation of the flex lane. One of the most challenging engineering decisions is how to build all of this without shutting down one of the region's most important bypasses. The tollway is doing it with staged construction under live traffic, keeping peak period capacity up, then shifting lanes and rebuilding the corridor in pieces. Work began near O'Hare in 2018 and at the south end in 2019, reached the central segments by 2021, and has run as a rolling work zone with reduced speeds and mostly overnight closures for beam sets, deck pours, and final tie-ins. But how much is all of this work going to cost? Rebuilding the road while keeping it open is expensive for the same reason it's hard. Although it may seem like it from an outsider's perspective, you're not just paving lanes, you're replacing an aging, load-bearing corridor piece by piece in a tight suburban right-of-way surrounded by bridges, railroads, utilities, and flood-sensitive waterways. The Illinois Tollway prices the central Tri-State program at about $4 billion, with the work expected to finish in 2027. The Tollway pegs the mile-long bridge project at about $500 million. At the network level, the most expensive node is the interchange we highlighted last section. The reconstruction is estimated at $700 to $800 million. The remaining cost is spread across mainline reconstruction contracts, dozens of local crossroad and rail structures, drainage and detention, right-of-way takings, major utility relocation, and all the ITS. So the natural next question is, how does this all get funded? The Illinois Tollway operates as a user fee utility, not a gas tax highway agency, and it states it receives no state or federal funds for maintenance and operations. So the core inputs are tolls collected today and toll revenue bonds backed by tolls collected tomorrow. The rebuild is funded under the Tollway's Move Illinois program, a 16-year, roughly $15 billion capital plan through 2027. To support that spending, the Tollway increased toll revenue with a 2012 passenger vehicle hike and phased commercial increases. The biggest technical argument against this project is induced demand, a set of predictable behaviors that show up once you reduce peak hour delay. When a corridor like I-294 gets more reliable in the short term, some drivers who were already traveling but were avoiding the worst periods will shift back into the peak. Some trips reroute from parallel facilities because the generalized cost, factoring in time, stress, and reliability, drops. Over time, freight schedules, commuting habits, and even nearby development can shift to take advantage of the corridor's improved throughput. So the bet here isn't that 294 will stay empty after you rebuild it. It's that the corridor won't break down as easily when it's full. Right now, the project is still in active staged construction. The Tollway's progress and published schedule still targets overall completion in 2027. If induced demand does show up, the end goal is that the better geometry, real recovery space, and active operations keep the beltway reliable instead of fragile. I'm Josh, this is BuildCore, thanks for watching.